So, in redox titration class, in the oxidation process of volumetric analysis, standard solutions of oxidizing agents and of reducing agents take the place of the acid and alkali solutions of the neutralization process already studied. So, take note that from our previous lesson, we have the titration of acid and a base to neutralize or to have a neutralization process. So in redox reaction, we have already the oxidizing and reducing agents. So this takes place class of the acid and the base or the alkali solutions. So we have important oxidizing agents as standard solutions. So what are this? If you're going to look at your notes or module, you have potassium dichromate, potassium permanganate, potassium ferricyanide. We have also iodine, ferric sulfate, potassium iodate, and potassium bromate. So these are the most common standard solutions. And how about the reducing agents? So these are in the form of standard solutions, which includes ferrous sulfate. Most common is also known as the ferrous ammonium sulfate or the FAS. Oxalic acid, sodium oxalate, sodium thiosulfate, and sodium arsenite. Okay, so what would be the combinations? Of course, you should have your oxidizing and reducing agent. Recall your first lesson, our first lesson in qualitative analysis and um, balancing of equation by redox. So important combinations are potassium dichromate and ferrous salts, potassium permanganate and ferrous salts. So if your oxidizing agent is potassium permanganate, your reducing agent is ferrous salt. Potassium permanganate and sodium oxalate is also another combination. Iodine and sodium thiosulfate, if you recall your activity in the lab in general chemistry, hypochlorites and arsenious acid as well is one combination. So in this problem, we are asked to solve for the normality of potassium tetroxalate. It is called a tetroxalate since we have here 3 oxalates. So this is potassium tetroxalate. What would be the normality of the solution as an acid and as a reducing agent? So no problem in determining the normality as an acid. So just use this formula. Normality is equal to weight times the factor divided by molecular weight times the volume in liters. So the factor here as an acid would be the replaceable hydrogen ion. So normality now would be equal to the weight, which is given 50.00 grams. What would be the factor as an acid? 2 replaceable hydrogen ion plus 1. So the factor would be 3 equivalents per mole. What is the molecular weight of potassium tetroxalate? Just add the atomic weights of each element or refer to your periodic table. So that would be 254.20 gram per mole, and we are given a volume per liter, so a volume of 1 liter. So the normality of this as an acid would be 0.59 normal. So this is as an acid. So what would be the normality as a reducing agent? We have here a formula. Normality as a reducing agent divided by the factor as a reducing agent is equal to the normality as an acid divided by the factor as an acid. Okay. If you have an oxidizing agent, that would be normality as oxidizing agent divided by the factor as oxidizing agent is equal to normality as an acid, factor as an acid. A base will always be base. So, no problem with base. Okay. So, if you're going to determine now the reducing agent, the normality as reducing agent, it is stated here that oxalate, so that is not oxate, oxalate is oxidized. So it is oxidized into carbon dioxide. Always, unless otherwise specified, but always class, the oxalate is oxidized to CO2. So you should know how to determine the factor. In determining the factor, that is the change of a reducing and oxidizing agent, that is the change in oxidation state. So oxalate here, C2O4, will be oxidized to CO2. Now, what would be the charge of carbon and the carbon in CO2? So that is oxalate is negative 2. So that is the charge of oxalate. So negative 2, negative 8, minus 2. So plus 8 minus 2, if you're going to transpose that, that is plus 3. Negative 2, negative 4, plus 4. So what would be the change in oxidation state now? The factor would be equal to higher minus lower, plus 4 minus plus 3 is equal to 1. How many oxalates do we have? So take note that there are 2 carbon rather in oxalate. There are 2 carbon per oxalate in tetroxalate. So if you're going to multiply that by 2, so take note, times 2, because there are 2 carbon atoms in oxalate, so that is times 2 is equal to 2. However, how many oxalates do we have in tetroxalate? 1 oxalate and another oxalate. So another oxalate. The 2 is not included there. So the factor now would be 2 times 2 is equal to 4 as a reducing agent. So normality now as a reducing agent would be N as a reducing agent. The factor as a reducing agent is 4 is equal to equivalence per mole is equal to normality as an acid, 0.59 normal. What is the factor of potassium tetroxalate as an acid? 3 replaceable hydrogen ion. So that is 3 equivalence per mole. Equivalence per mole. So the normality now as a reducing agent would be equal to 0.559 normal times 4 equivalence per mole divided by 3 equivalence per mole. And you will get here a value of 0.787 normal. So that is how you're going to determine the normality as a reducing agent. So you should know first the normality as an acid. Or if you're asked to solve for the normality of the acid given the normality of the reducing agent, so you have to know the factor of the reducing agent or oxidizing agent and the factor of the acid as well.